Hi students, today let's talk about AM3 functions. In the challenges questions, let set x equals 1, 2, 3, 4. Verify which of the following relations are function from x to x. Here function 1 is given 1, 1, 2, 3, 3, 4, 4, 1. Means the first component is domain, second one is range. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 3, 4, 1 means 1, 3, 4, 1. We are doing the relation from x to x, that is f1. Now we need to tell whether f1 is function or not. The relation f from x to x is nothing but 1, 2, 3, 4, 1, 2, 3, 4. Whether this relation is function or not. First we need to check all the elements associate with some elements in this set. Yes, it is. Now then it is said to be function. If every element of set X associate with distinct element in the set, this X set, then function f1 is said to be function. The relation f1 is said to be a function. Now second one, function 4 equals 2, 1, 3, 4, 1, 4, 4, 4. The relation from x to x, this is f4. X is nothing but 1, 2, 3, 4, 1, 2, 3, 4. f4 relation is given 2 associate with 1, 3 associate with 4, 1 associate with 4, 4 is associate with 4. So now this f4 is said to be function because every element of set x associate with some element in the set x, therefore f4 is a function. Next question, let x is 1, 2, 3, 4, 5 if the relation g 1, 2, 2, 3, 3, 4, 4, 5, 5, 1 on x is a function from x to x, then g of g2 and g of g4 we need to find. Here let me take, this is set x, this is also set x. The function g from x to x, so x to x, g is the relation. Now 1 is associated with 2, 2 is associated with 3, 3 is associated with 4, 4 is associated with 5 and 5 is associated with 1. Now we should find this value. Let me take that. Now g of 2, first this value I am finding, g of 2. When for the function g, if I substitute 2, what I am getting? 3. So g of 2 value 3. Now g of 3, for this g function, when input is 3, what is output? 4. Now g of this 4, input is 4, output is 5. So the value of g of 2 is 5. Similarly, g of g4, for this function g function, input is 4, then what is the image for that? 5. Now g of 5, input is 5, output is 1. For g of 1, input is 1, output is 2. Now question number 3, if fx equals minus 5 plus 7 when x is less than minus 1, 1 plus 4x when x is more than minus 1, less than 2, fx equals 6 when x is more than equal to 2, less than 5, fx equals 11 minus x when x equals more than equal to 5. we should find f of 1, f of 6, f of minus 2, f of 3. Let's do one by one. Let me find this value, f of 1. 1. It is, here they have given 4 functions. Which function we need to take when x equals 1? This function when x equals less than minus 1. This function x is more than minus 2, less than 2. Means more than minus 2 means in the number line 0, 1, 2, minus 1, minus 2, 3, 4, 5. See, x value is 1. X value 1 means it is more than minus 1 and less than 2. So that this function I should take 1 plus 4x. Now substitute x plus 1. 1 as it is. 4 1s are 4. 4 plus 1, 5. Next, second one. Here f of 6. 6 is more than 5. Yes or no? The 6 is more than 5. Now above 5. Above 5 means the function is 11 minus x. Therefore f of 6 time we should use 11 minus x. Now x place you substitute 6. 11 minus 6 is 5. Next, f of minus 2. First let us find the answer for this. F of minus 2. Minus 2 means imagine number line 0, minus 1, minus 2. 1, 2, 3, 4, 5. Minus 2 means, look at the condition. When x is less than minus 1. Less than minus 1 means minus 2, minus 3, all are less than minus 1. Therefore, when x is minus 2, we need to take these first conditions. Minus 5x plus 7. Because the condition is x is less than 1. Here x is minus 2, so we should take this function minus 5x plus 7. Now x place substitute minus 2. Minus into minus plus, by 2 is 10, plus 7 is 17. After that, substitute f of minus 2 value here. Now, this f of 17 is left. 17 is above the 5. Above the 5, the function we should consider 11 minus x. This function now is considered as 11 minus x. Now x place you substitute 17. 11 minus 17 is minus 6. Similarly, next question number 4. f of 3. F of 3 we should find. 3. 3 means it is more than 2, less than 5. Yes or no? More than 2, less than 5. More than 2, less than 5. That time what we should take function? 6. The function we should consider as 6. So f of 3 is equal to 6. Now we should find f of 6. 6 is above the 5. Above the 5 condition is what? X is more than 5 means we should take this function. So 11 minus x. X plus 6 you take. 11 minus 6 is 5. So f of 6 is 5. Now f of 5. F of 5 means which function? See, x is more than 5 or equal to 5. That time we should use this condition. Therefore, f of 5 time we can take this function 11 minus x. So now this function is equal to 11 minus x. X place take 5. 11 minus 5 is 6. It's very simple. By seeing the conditions, which function we should take, that is very important. First f of 3 is above the 2, below the 5. So in such case, above the 2, below the 5 means function is equal to 6. Therefore f of 3 plus 6. Now f of 6, which one condition we should see? Above the 5 means this condition 11 minus 6. Now we are finding f of 6. 6 is above the 5 means condition we should take 11 minus 6. 6 in the place of x you take 6, you will get 5. Now f of 6 value 5. Now f of 5 are above the 5, same condition 11 minus 6. So take 11 minus 6, substitute x value, you will get the answer. Yeah. Question number 4. Function f from a to b, then find the range of f where a is 1, 2, 3, 4 and fx is x square plus x plus 2. Now function is given and domain also given. Okay. Now substitute this x plus 1. Wherever x is there, 1. 1 square, 1, 1 plus 2 plus 1 is 3, 3 plus 1, 4. When x equals 2, you will get 8. When x is 3, you will get 14. When x equals 4, we will get 22. Now look here, this is set A, contain 1, 2, 3, 4. When you substitute 1, 2, 3, 4 to the function, what we are getting? 4, 8, 14, 22. 1 is associated with 4, 2 is associated with 8, 3 is associated with 14, 4 is associated with 22. This set A is nothing but domain, set B is nothing but codomain, and these are the images for 1, 2, 3, 4. These images are said to be range. So they are asking find the range for the function f. Range is 4, 8, 14, 22. Yes. F of x equals x plus 1 by x minus 1. Show that f of x plus f of 1 by x is 0. We know the value of f of x. We don't know the value of f of 1 by x. So let us find that. We know that fx means x plus 1 by x minus 1. Now x plus 1 by x, if I take, wherever x is there in the function, take 1 by x in that place. Now this 1 I can write x by x. Then x is LCM, like fractions, denominators are same, add the numerators. Denominators are same, subtract the numerators. Now divide this fraction by this fraction. First fraction as it is into reciprocal of second. X cancel. What is left? 1 plus x, 1 minus x. Now f of x plus f of 1 by x. F of x, we know that x plus 1, x minus 1, plus f of 1 by x, what is the value we found? 1 plus x, 1 minus x. Now this fraction I will write as it is, plus numerator 1 plus x as it is. Here 1 and minus x. In these two I will take x common. Then x into 1 minus x. Minus into x, minus x, minus into minus, plus 1. Here 1 is nothing but plus. So minus into minus plus, minus into x is nothing but minus x, minus minus plus 1. Same thing, 1 minus x, I can write it as minus of x minus 1. When you multiply this, you will get 1 minus x only. Now plus into minus, minus. Here 1 plus x, x minus 1. Now look at the denominators, x minus 1, x minus 1, same. Then simplify the numerator, x plus 1 as it is, minus 1, minus into plus, minus x. X cancel, 1 cancel, remaining 0 by x minus 1. 0 divided by anything is 0. Hence it is proved. Okay, na? Here I took the minus common between these two. When I take minus common, minus into x, minus into minus, plus 1. This plus and minus you multiply. Then LCM is same, because denominators are same. Subtract the numerators. Subtracting time we should remove the bracket, so multiply the sign. X cancel, 1 cancel, 0 by anything is 0. Yeah. Now state which of the following are one-to-one and onto function. Remember, one-to-one means every element of set A should have distinct element in set B. That is one-to-one. Onto means range and codomain should be equal. Okay. Here the function f r to r is defined f of x equals 2x plus 1. This is linear equation. Yes or no? 2x plus 1. Students, very important note, every linear equation is one-to-one and also onto. Every linear equation is bijective. Okay, it satisfies one-to-one condition, onto conditions. If you want, let us check. So r to r, real number to real number. Real number means positive, negative, all numbers will be there. If you take x plus 1, you will get 3. X plus, if you take 2 minus 2, you will get minus 3. X plus, if you take 0, you will get 1. If x is 5, you will get 11. Okay, so you take any value from the set R, there will be some image in the set R. Therefore you can assume this is set A, this is set B. Every element of set A having some image, then it is one-to-one, distinct image. Okay, and look at the range. Range is here in this example I have 4 elements in the range, 3 minus 3 1 11. Codomain also same. So range and codomain are equal, then it is onto. Therefore the function is one-to-one and onto, then the function f is bijective. But they are asking one-to-one or not. So look at this and say yes, it is one-to-one and onto, because range and codomain are same, therefore onto. Every element of set A having some image in the set B, therefore function f is said to be one-to-one. Here A means you consider as R, B also R, real number to real number. The next question, here second one, f is a function R to set x such that x is more than 0, and function fx defined x square. Assume this is set A, this is set B. B is defined x is more than 0. Okay, and here set A is defined all the real numbers 1 2 3 minus 1 plus 1, all numbers can take, and function is defined x square. If I take 1 square value 1. If I take minus 1 square value 1. If I take 2, I will get 4. If I take minus 2, I will get 4. See, every element of set A having some image in the set B, then it is one-to-one. No. See, different two elements having same image, then f is not one-to-one. What is the one-to-one meaning? Every elements of set A should have distinct element in the set B, but two different elements having common image, then f is not one-to-one. It is many-to-one function. Many elements having same image, so it is not one-to-one. And look at the range. Range is same. This is domain, this is codomain. Range is 1 and 4, codomain also 1 and 4. Range and codomain are equal, then it is onto. So it is not one-to-one. Whether it is function or not, yes, it is function, because every element having some image. Why it is not one-to-one? Different element having same image. One-to-one means every element should have distinct image, but it is not. So it is many-to-one function. The function is not one-to-one, it can be a many-to-one. Okay, na? And it is not bijective, because both one-to-one and onto, if it is satisfied, then it is bijective. It is not. Here, third question, the function f r minus 2 to r minus 1 means set r, it is one set A, this is set B. All the real numbers you should take except 2. All the real numbers you should take except 1. That is the condition, A to B. First, whether it is function, yes, all the elements are associated with some elements. Whether it is onto, look at the range and codomain are equal, then it is onto. Okay. You may think this is function if x equals 1, 1 plus 2 is 3, 1 minus 2 is minus 1, minus 3. If x equals 2, you should not take, you can take 3. If you take 3, 3 plus 2, 5, 3 minus 2, 1, it is 5. Like that, if you take any element, either it is positive or negative, you will get some image in the set B. But you may think, why they given this minus 2 is not included for this, or minus 1, sorry, why we should eliminate this 1, why we should eliminate this 2, let us discuss. Students, if you take 2 in the set A, what image you may receive? Let us discuss. What is the function? Function is x plus 2 by x minus 2. X plus, if I take 2, 2 plus 2, 2 minus 2. 2 plus 2 is 4, 2 minus 2 is 0. Any number divided by 0, we cannot define the value. So that we cannot define the image in set B when you take 2 in the set A. That's why all the real numbers you should take other than 2. Then you can ask me, why they given here r minus 1, sir? Means assume sum of the element having image is 1. Okay, na? Some x value, when I substitute x plus some value, I am getting 1. Okay, so f of x is nothing but 1. What is f of x means? X plus 2 by x minus 2. Now transpose this left side, x minus 2 equals x plus 2. Both x will get cancelled, whether it is equal, minus 2 and plus 2. So what I supposed to find? X value. When, at what value of x, my answer is 1. But x only is getting cancelled means there is no such elements in the set A to get the value of 1. Therefore x cannot be defined. Therefore they are saying all the elements we can take except 1. Okay, na? Because there is no such x values in the set A to get answer is 1. No element in the set A for that image is 1. That's why except 1. Why except 2? Already I told, if you consider 2, image cannot be defined. That's why they are telling r minus 2, r minus 1. Okay, now by seeing this, every element has some distinct image, therefore it is 1 to 1, and range and codomain both are equal, therefore it is onto. So through this example we can understand the function f is 1 to 1 and onto. Here, if fx equals x plus 2, g of x equals x square minus x minus 2, find this value. Functions given f function, g function. Here we need g1, g2, g3. Let us take g of x function and substitute x plus 1, you will get minus 2. If x plus 2, you will get 0. 2 square minus 2 minus 2. 2 square is 4, 2 minus 2 minus 2 minus 4, 0. Similarly, x plus, if you take 3, 3 square minus 3 minus 2, you will get 4. Next I will take fx. Here I need minus 4, minus 2 and 2. Minus 4 when I take x plus, minus 4 plus 2, you will get this. When x is minus 2, you will get 0. When x plus, if you take 2, 2 plus 2 is nothing but 4. So what are the values I need? I found it here. Now just I need to substitute. G of 1 minus 2, g of 2 is 0, g of 3 is 4, 4 minus 2 is 2, f of minus 4 minus 2, f of minus 2 0, f of 2 is 4, 4 minus 2, 2, 2 by 2, 1. This is the value for that. Yeah, some important note for you. The number of possible function from a to b, a is one set, b is another set. How many possible sets we can find? N of b whole to the power of n of a, n of b whole to the power of n of a. This is formula to find number of possible functions from a to b. Next, the number of possible function when the function is 1 to 1 from a to b. How many possible 1 to 1 functions we can find? There will be two conditions arise. Set A is number of elements of set A is more than number of elements of set B. Then there is no 1 to 1 function, because number of elements of set A is greater than number of elements, means it will be many to 1 functions. For example, suppose here 1, 2, 3 number of elements, here A, B. Okay, 1 to 1 not possible. Either this will be many to 1 function. For that case, if number of, this is set A, set B, number of A is greater than number of B, 1 to 1 functions is 0. Now number of A is less than the number of B. How many possible 1 to 1 function? N of B, P, N of A. What is this? It is nothing but permutation, n pair. This I will explain in the next. After this formulas, I will explain how to find n pair and NCR. Permutation formula is factorial n by n minus r factorial. What does it mean? I will explain. So remember, number of 1 to 1 function from A to B set when number of elements of A is smaller than number of elements, that is n of B, P, n of A. Okay, that means permutation you should do. Here the number of possible onto function from A to B. Here again two cases arise. First one, number of A set A is m, number of B is 2, only 2 elements. Then how many onto functions? 2 to the power of m minus 2. Remember, number of B must be 2. Case 2, number of elements of set A is m, number of elements of set B is n, different elements. Then nc0 n power of m minus nc1 n minus 1 whole power of m. Remember, this is plus minus, it will continue. Okay, nc1, nc2, nc3. Okay, and n minus 1, n minus 2, n minus 3 powers are same. Okay, if I take example, you may understand. It is there in the exercise. I will explain that time. Now the number of possible into function. What is into function? Range and codomain are not equal. That is into function from A to B. If number of elements of set A is m, number of elements of set B is m, then nc1 onto function nc0 it start, into function nc1, nc2, nc3 so on. First sign is plus, after minus, plus minus plus minus. Then n minus 1 whole power of m. This whole power of m also common. n minus 1, n minus 2, n minus 3. Okay, so almost these two are very similar formulas, but here nc0 it start, and here it start from n power of n. Okay, after n minus 1, n minus 2, n minus 3. Here n minus 1, n minus 2, n minus 3 powers will be m only, but it start from nc1, nc2, nc3 plus minus like that. Next, number of bijective functions from a to b. Number of a and number of b both should be equal. Remember, then only bijection happen. Number of a and number of b both are equal, then anything number of possible bijection function is, you can take number of a factorial or number of b factorial, any one, to find the bijection. Now let us discuss how to find the NPR and NCR. What is permutation? What is combination? Here permutation means arrangements, combination means selection. Formula factorial n by n minus r factorial for NPR. For NCR, factorial n by n minus r factorial. Factorial symbol is this or this. So this formula I can write factorial n by n minus r factorial into r factorial. This way also we can rectangle angle symbol also we can use, or this symbol also we can use for permutations and combination time. Factorial time we can use this symbol, or angle symbol also we can use. First understand what is this factorial means. Suppose 5 factorial, what does it mean? 1 to 5 natural numbers product. What is factorial 4? 1 to 4 factorial, 1 to 4 natural numbers product is factorial 4. What is factorial 3? 1 to 3 natural numbers product. Okay, factorial 0 value always 1, remember. This is about factorials. There is some properties. Suppose np3 you want to find. Formula factorial 5, n plus 5, n minus r, 5 minus 3 factorial. Factorial 5 means 5, 4, 3, 2, 1. Factorial 2 means 2 into 1. 2, 1, 2, 1 get cancelled, product is 60. Similarly, some properties about NCR. Last year 8th class you learned. Just recollect. Both n and r, if n and r same, the value of NCR equals 1. If r is 0, then the value of NCR is equal to n. 3c3, 4c4, 5c5, 10c10, 100c 100, the value is 1. 3c0, 2c0, 100c0, the value is nothing but the number itself, n. What is n? That only. Okay, these are very simple tips which we discussed in the last year class, that you need to use in this question. Now let's go to the question number 8. Set A given, set B given, 1, 2, 3, 1, 2, 3, 4. Then find the number of possible 1-to-1 function. 1-to-1 function, here A has 3 elements, B has 4. So B is greater than A. So we can use this formula. N of BP, N of A. Okay, formula is this. Okay, now let's take number of elements of A is 3, N of A is 3. Number of elements of set B is 4. Now number of elements of B, P number of elements of set A. So 4P3. Remember the formula, NPR formula. NPR formula factorial n by n minus r factorial. So factorial 4 by 4 minus 3 factorial. Factorial 4 means 4, 3, 2, 1. 4 minus 3 is 1. 1 factorial is nothing but 1. 1, 1 get cancelled. 4, 3 into 2 is nothing but 24. There we can find 24 possible 1-to-1 function. Okay. there you need to apply just NPR concept. N is number of elements of set B and R is number of elements set of A. Now question number 9. State whether the function f a to b is defined fx equals 3x minus 2. This is linear equation. From a is 1, 2, 3, 4, 5, b is 1, 4, 7, 10, 13 is 1 to 1 or not. Now let us find the values for them. If you take the function 3x minus 2 and substitute set a input, means whatever values they have given in the set a, that you substitute in the function and find the values. If I substitute 1, if I substitute 2, 3 means this, 4 means 10, 5 means 13. So 1 is related with 1, 2 is related with 4, 3 is related with 7, 4 is related with 10, 5 is related with 13. So every element having distinct image in the set B, therefore function is said to be 1 to 1 function. Number of A is 5, number of B is 5. Both A and B are same. Then number of possible bijection. When number of A and number of B both are same, number of possible bijection formula either number of A permutation, factorial of number of A or factorial of number of B. So factorial of 5 is 5, 4, 3, 2, 1. Product is 120. Question number 11. Number of A is 4, number of B is 3. Then find the number of possible into function. So into and onto, remember. Here there are two cases for into. When n equals n of A is m, n of B is 2, 2 power of m minus 2. Number of elements of set A is m, number of elements of set B is n. Number of into function will be nc1, nc2, nc3, like that it start. But remember, on to time formula will be nc0, nc1, nc2, nc3, like that it will start. Okay, you need to remember all the formulas, then you can able to answer. Here the formula is this. First one is plus, after minus, after plus, like that. Why I stopped only till here, you will come to know. Where m equals, they given in the question, number of elements of set A is 4. So m is 4, number of elements of set B is 3, therefore n of n is 3. M is nothing but number of elements of set A, that is 4. Number of elements of set B is 3, that is n is 3. Now formula is this. Substitute n plus 3. So 3c1, 3c2, 3c3. 3c4 it is not possible. Okay. After nc1, m value, wherever m's are there, take 4. Now n place 3. 3 minus 1, 2, 3 minus 2, 1, 3 minus 3, 0. 0 is with anything is nothing but 0. 1 power of 4 is nothing but 1. 1 into 3 is 3. 3 minus 1 is 2. 2 power of 4, 16. 16 3 is 48. 48 minus 3 is nothing but 42. There we can find 45 types of possible into functions when number of A equals 4 and number of B equals 3. Remember the formula, that is nc1, this is plus minus n minus 1 whole power of n minus nc2 n minus 2 whole power of n plus minus plus nc3 n minus 3 whole power of n. Okay. N and R both are same means value is 1. N and n, which means R is 1, the value is equal to n. Okay. 5c1, the value is 5. 16c16, both n and R same, then answer is equal to 1. So all these tips you need to remember. Now parallel package. If f is a function, R to R is defined by f of x equals x square plus 1, and then f of x square minus 1 value we should find. Fx given, then we should find this value, x plus x square minus 1. This x plus I am taking x square minus 1 square as it is. This is nothing but a minus b whole square. A minus b whole square formula, a square plus b square minus 2ab. Just substitute x square whole square value x power of 4, 1 square value 1, minus 2 ones are 2x square plus 1. Now x power of 4, 1 plus 1 is 2, minus 2 x square. Next, set A is 1, 2, 3, set B is A, B, C, D, and f function is given. Then f is which type of function? If you see, 1 is related with A, 2 is related with B, 3 is related with D. Means every element related with different elements. Then f is nothing but one-to-one function. Now f is given 0 and 1. 2 minus 1 to 1. Minus 1 to 1 means minus 1, 0, 1. Remember the number line. Minus 1 to 1 means there are 3 numbers between them. Minus 1, 0, 1. Okay. This is domain and this is codomain. Domain, codomain. Domain is 0 and 1. Codomain is minus 1, 0, 1. Function fx is defined x square. If x plus if you take 0, 0 square is 0. X plus if you take 1, 1 square is 1. So 0 is related with 0, 1 is related with 1. Now f is nothing but, whether it is a function, yes, because every element of domain having some images, therefore it is a function. Then is it one to one? Yeah, every element having distinct image, that's why it is one to one. Whether it is onto, no, because range is 0 and 1, but codomain is 3 elements, range is only 2 elements. Range and codomain are not equal, then it is not onto. So the option both A and B is correct. A also correct, B also correct. So the right option is both A and B. So you need to choose the option. Right option is this D, because it is saying both option A and B. If set A is ABC, set B is 2, 1, 0, then function is defined like this. Then f is dash. A is related with 2, B is related with 0, and C is related with 2. First, whether it is function, yes, because all the elements have some images. Whether it is 1 to 1, no, because 2 elements having same image, so it is many to 1. Whether it is onto, no, because range is 0 and 2, but codomain is 1, 2, 3. That means 3 elements are there in codomain. Range is only 2 elements. So range and codomain are not equal, so it's not onto. Whether it is constant, no. Constant function, we will discuss in the next lesson. So every element having only one image. You take any elements, image is only one single constant, then it is said to be constant function. Every element of set A, if they having the same image, so for example 1, 2, 3, all are having the same image A, then it is said to be constant function, but it is not, so it is only function. Here A is given 3, 0, 1, 2. Function f from A to B is an onto function defined by fx is this. Then B is what? See, this is linear equation, definitely it is 101 and onto, that is bijective function. Now what they are asking, A is given, we need to find the image. Okay, function is defined, so wherever x is there, take 3, once 0, after 1, after 2, find the values. Then you can say 3 related with 4, 0 related with minus 5, 1 is related with minus 2, 2 is related with 1. So these are nothing but set B, because they are the images of these 3, 0, 1, 2. Images are 4, minus 4, 5, minus 2 and 1. So this is nothing but set B. They asked us to find the set B. Set B is this. You can arrange this in the order, which is leftmost -5, after -2, after 1, after 4. Remember the number line. Both are same orders, you can rearrange and write. Maybe option will be like this. Check it. Now set A is 1, 2, 3, set B is 1, 2, 3, 4. Then the number of possible functions from A to B. Formula is number of B whole to the power of number of A. Number of B is 1, 2, 3, 4. Whole power of number of A is 1, 2, 3. 4 power of 3. 4 4s are 16, 16 4s are 64. If your answer is 4 power of 3 or 64, both are same. Check your options, then choose the right one. Here the number of one-to-one functions can define from this set A and set B. Assume this is set A, set B. Set A has 3 elements, set B has 4 elements. Okay, what is the one-to-one function formula? N of B P N of A. Number of elements is 4. P, number of elements of set A is 4P3. Means formula, NPR formula. NPR formula is factorial n by n minus r factorial. So factorial 4, 4 minus 3 factorial. Factorial 4 is 4, 3, 2, 1. 4 minus 3 is 1, 1 factorial is 1. 1, 1 cancel, 4, 3, 2, product is 24. Set A is 1, 2, 3, 4, 5. Set B is A, B, C, D. Then the number of possible one-to-one function. One-to-one, there are two cases. Before case, just I will show you. Yeah, here number of elements B is greater than number of elements of set A. Then we can use this NPR concept. N of B, P N of A. Okay, but in the second case, number of element is more than number of B. Then number of possible one-to-one function is 0. Because I already told you, if there are 3 elements in set A, set B has only 2 elements. One is related with A, 2 is related with B, then 3 either it may related with A or B. Then it is not one-to-one, it is many-to-one function. There is no possible one-to-one function, that is 0, because n of A is greater than n of B. Emerald package. If function f is R to R is defined by f of x is given, and we should find f of x square minus 3x minus 2 value. Okay, now function what they given, let us take. Now we should find this value. So x place you should take x square minus 3x minus 2, x place. Now fx given x square minus 3x plus 2, that is function. Now x, wherever x is there you should take this x square. So x place take this square minus 3 x place this plus 2. This is one identity which you learnt in the class 9. A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab 2bc 2ca. Yes or no? Same formula I can apply over here. A square, a plus x square whole square, plus formula plus b square, b plus what is there, minus 3x whole square, plus c square, c plus what is there, minus 2 ka square, plus 2ab, 2 as it is, a is this, b is this, plus 2bc, 2 as it is, b is this, c is this, plus 2ca, 2 as it is, c and a, c is nothing but minus 2, a is nothing but x square. Just you need to compare this and substitute this value by comparing this. Okay, now minus 3 into this, minus 3 into x square, minus into minus plus, 3 3s are 9x, minus into minus plus, 3 2s are 6, plus 2 as it is. So these are nothing but answer of this. These are nothing but when I multiply 3 with this 2 is as it is. Now simplify. X square whole square x power of 4 minus 3x whole square, minus square will be plus, 3 square is 9, x square as it is, minus ka square is plus, 2 ka square is 4, plus into minus, minus 3 2 is 6, x square into x cube, plus into minus, minus minus into minus, plus 3 2 is 6, 6 2 is 12, x as it is, plus into minus, minus 2 2 is 4, x square, minus 3x square, plus 9x, plus 6, plus 2, x power of 4 as it is. Okay na? 9x square minus 4x square and 3x square, all these are like terms, x square x square x square. Simplify. 9 monkey minus 4 monkey, 5 monkey left, 5 monkey minus 3 monkey, 2 monkey, monkey is nothing but x square. Now x cube anywhere, no, minus 6x cube as it is. Now x, 12x plus 9x, total 21x. Now numbers, 4 plus 6 plus 2, 12. This I will arrange in descending order, x power of 4 after x cube, after x square, after x and constant. This is the answer. So here you need to apply a plus b plus c whole square formula, a square plus b square plus c square plus 2ab 2bc 2ca. Wherever a is there, x square, b means minus 3x, c means minus 2, you will get this. Okay, then after simplify you will reach the answer. Now question number 2. Now f is r to r defined, f of x equals x plus 2 when x is less than minus 1, x square when x equals more than minus 1 and less than equal to plus 1, 2 minus x when x equals more than 2. We should find the value of this. First let me find the value of this. Look at this, this is less than minus 1, yes or no? If you imagine the number line, this is minus 1, this is minus 2, minus 1.75 means when you move towards the left side, the values will be less than the right hand side. So when you compare this minus 1.75 and minus 1, this is greater, minus 1. So this value is less than minus 1. Condition is less than minus 1, condition is x plus 2. So x place you take this plus 2. When you subtract these two, you will get 0.25. Now next 0.5. 0.5 means which condition I should take in these three. See 0.5 minus 1 after 0 will come, 1 will come. 0.5 is here. Okay, this 0.5 is above the minus 1, below the 1. So above minus 1, below 1 means x square. So take x square. So x plus 0.5 whole square. Multiply, you will get minus 0.5 whole square is nothing but 0.5 into 0.5, 0.25. Next I need this. So 1.5. Look at this. It is 1. This is 2. 1.5 will be here. It is above the 1. Above 1 condition is 2 minus x. So x plus take 1.5. Subtract, you will get this. Now this plus this plus this. When you add these three, you will get 1. Now statements. Statement A says f of a equals b. Then function f a to b is called into function. It is wrong. Okay. Statement B. F of a is subset of b. Then function f a to b is onto function. That is also false statement. Okay. Both a and b are false. Next one. Statement A. The function which is not an onto, it is called many to one. This is the function. Whether this is onto or not. Onto means range and codomain should be equal, but range is 1 and 4, codomain is 1 2 3 4. Range is not equal to codomain, so it is not onto. Then this is function because all the elements are having some images, and if it is not onto, then it is many to one function, so it is true statement. N of a given number of bijective a to a function formula, either n of a, we need to find the factorial value. So a is nothing but 6 factorial, 6 5 4 3 2 1 is 720. Both statements are true. Statement A, if function f a to b is injective, means 1 to 1. Function x1 is not equal to x2, that influence f of x1 is not equal to f of x2. True statement. Suppose two different elements x1 x2 we are taking, we are getting different values a b. This is function f of x. So when I take f of x1 and f of x2, x1 time I am getting a, x2 plus I am x2 case I am getting b. A is not equal to b, therefore f of x1 is not equal to f of x2 is true statement. Every bijective function is surjective function. Every bijective function is surjective function. Yes, true. What is surjective? Onto function. It has to be. Then both statements are A and B true statement. 1 to 1 is called injective. Onto is called surjective. If both cases it is satisfied, then it is bijective. So every bijective function is surjective function. True. Then both A and B are true. If it is 1 to 1 and onto, then it is bijective. To say onto, bijective, it must satisfy 1 to 1 and onto. So the function, if it is satisfy the onto and 1 to, then it is bijective. Now bijective function, every bijective function is surjective. If it is surjective only, injective and surjective only, we will call that is bijective. So every bijective function is surjective function. If the range of function is equal to its codomain, then it is onto true. A to b function is said to be into f of a is subset of b. It is statement. So both statement A and B are true. This is the definitions only. So both statement A and B are true. Next, statement A is given, B is given, then number of 1 to 1 functions A to B is 8. So statement A is false, because A is greater than B, then there is no 1 to 1 function. Next, number of 1 to 1 function from A to B is defined number of B, P number of A, when number of A is smaller than number of B. Statement B is true because this is a formula condition. Statement A is false. So A is false, B is true. More than one type of question. F is defined R to 0 to infinity. R is real number, 0 to infinity is a codomain. This is domain and this is codomain. Define fx is define x square. If you take 0 का square, 1 square minus 1 square, root 2 square is 2, root 3 square is 3, 2 square is 4, minus 2 square 4. You take any values, you square that, you will get some values that will be positive and more than 0. So if you look at this, every element having some images, so it is function. Is it 1 to 1? No, because two different elements having same image, so it's not 1 to 1, it is onto. Therefore these two are the correct. If it is 1 to 1 and onto, then we can say bijective. Now f is defined R to R, real number to real number. Fx is defined x cube, then which is the correct? If you take 1 cube is 1, minus 1 if you take minus 1 you will get 2 cube 8, minus 2 cube minus 8, 0 if you take. So you take any element, there is some image, so it's function. every element has different images, so it is one to one. And image and range, all the images group is nothing but range. Range and codomain, if you compare, both are equal, so it is onto. When it is one to one and onto, then it is bijective. So now f is a function q to q. What is q? Rational number. Rational number means p by q. P and q belongs to integer and q is not equal to 0. That means all positive, negative numbers 0, including that fractions also will come. Okay. Now function is defined 2x plus 3. Whether which is correct answers. If you take 0, you will get 3. If you take 1, you will get 5. If you take half, you will get 4. If you take minus 2 by 3, you will get 5 by 3. You take anything 0, 1, 2, 3, positive fractions, negative fractions, there will be some different images in set Q. Therefore, it is a function and it is one to one and it is onto, because range and codomain, this is codomain, this is domain. All the images group is nothing but range. Range and codomain are equal, so it is onto. When it is one to one and onto, it is bijective. So that all the options are correct. Diamond package answers have given here. Please try by your own. Okay. Thank you, students.